All right, well, once again, good morning, everyone, and welcome back to another exciting day in mathematics. Woo, woo. Warm-up 52 should come up on your screen. Set that aside to whatever you were working on. Make sure your mobile devices are put away, and AirPods and such. Today we're moving on. We're done already with measures of central tendency, measures of variation. We're moving on to the third measure. We're going to see that today. So I'll give you guys, let's see, 1 and 2 on warm-up 52. I'll give you about 7 minutes. Go. All right. So for the sake of time, here we go. Measure central tendency. Mean, what'd you get for the mean? Ricardo. 3.4? 2.4. How about a median or Q2? 2? 1.5? You said 1.5? Okay, let me look at this. 1, 2, 3, 2 twos. 2, 3, and 4. By looking at it, what is the median, Ricardo? 2. All right. And all we need is the mode. 2. All right. So I need Q1. I already have Q2, which is 2. For my box plot, pass them on, Ricardo. Darian, what'd you get for Q1? 2? Okay. $1.5. How about Q3? 3.5. Max is 4, and min is 1. Hands, if you got something like that. Looks about right. All right. Let me get my bell curve going. Yeah. A little lopsided. Hold on. Let me fix that. A little bit better. And we said that the mean was what? Mean was 2.4. 1 standard deviation. Up and down for our norm. Not Chevy Chefs, but our normal norm, which means we need a standard deviation. So, share with your neighbor what you got for standard deviation. Approximately. All right. Who went last? Darian? Pass someone? Martin. Standard deviation. 1.01. Hands, have you got that? Yeah, pretty close. And if you did, it depends if you went the long way or if you used a shortcut, you're going to be off by maybe tenths of a decimal. That's all right. So that means we are at 3.41 or 1.30, what? 39. And that's our norm. All right, send me your warm-up, please. By now we are experts at these two because we already finished those measures of central tendency and measures of variation. The only thing we didn't compute here was the range. Bless you. Was the range. Our agenda for today, warm-up number 52, measures of position. We're moving on. And tonight's home play, page 159, numbers 10 and 11 only. 10 and 11 only. What's that? Oh, my bad. Give me a second. Let me send you a blank screen because somehow It glitched. Nice. Oh my goodness. Mm-hmm. All right, we good? All right. Copy the code for the home play access 8Q6KS. 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 All right. All right, and also thanks to those of you that have been donating blood. Those of you that haven't, think about it maybe in the future. All right, that's tonight's home play. Yesterday was study your formulas, yes, because today we're going to add some more. Let's go. All right, get a Cornell note going, please. I can summarize data and compute the measures of position. I can summarize data and compute the measures of what? Position. Yeah, we're done with central tendency. We're done with variation. Now we're moving to measures of position. That is correct. Okay. So, get that ready, please. Give you some time. And it looks like weather, it's going to get a little windy today, so it can cool off a little bit more by tomorrow. Oh, yeah. All right. So, by now you should know how to fill that up on your screen. Fill it up as much as possible. I'll give you guys about a minute. Go. 1 minute. Type it in. It's blank. Oh my goodness. All right, do me a favor. It looks like it's going to be glitching like that for the rest of the presentation on Nearpod. Share with your neighbor the 3 different measures that we are covering. All right, looks like Vanessa's got it. Vanessa, what is the first one? Central tendency, and what are they? Mean, median, and mode. How about the next one, Donna? And the last one, JJ? There you go, position. Yeah, today we're going to learn what 3 of those are positions. Very good. All right. And again, I'm not going to send you this screen, but remind your neighbor the definition of measures of position. You're like, we don't know that yet, Mr. Q. All right, get a fair model going, please. What are measures of position? So yesterday, again, we kind of recapped, said measure of central tendency gave us the center of the data. Measures of variation gave us how the data is distributed. Is that correct? Or spread through. Measures of position shows us exactly or right about where a certain data falls within that spread. Okay? So definition, write this down. Commonly used measures to locate the relative position of data values in a data set. I'll repeat that again. Commonly used measures, notice that's the beginning for all 3, to locate the relative position of data value in a data set. Relative position of a data value in a data set. Relative position of a data value in a data set. And those measures are 4 of them. The first one is known as standard scores. Standard scores. The second one, percentiles. Percentiles. The third one, quartiles. Quartiles, and we've been looking at those already with our measure of central tendencies, right? Q1, 2, and 3, right? Yes, Mr. Q. All right. And then the last one, deciles. Deciles. We're going to be looking at those as well. And today's going to be a smooth intro. We're going to get started with standard scores. And standard scores, by the way, guys, is also known, label it, here goes. This is what we're going to focus on today. This is known as Z-scores. And watch, when you guys get to college or to wherever you're going for your studies and you take your statistics class, this is one of the main concepts you're going to be looking at throughout your statistics course, Z-scores. But like I said, most colleges or universities just have you plug in stuff on a calculator, and I don't like that. That's why you're doing the hard work here so that you memorize it, even if you're at Walmart late at night, right? You'll be like, oh, Z-score, but there it is. Let's go. All right, so today we're going to focus on Z-scores. Percentiles, pretty obvious, yes. Quartiles, pretty obvious, yes. Deciles, we'll get to that as soon as we get through some of these sessions. Non-examples, you can either write mean, median, mode, or what else can you write in there for non-example? Tell your neighbor, what else can you write for non-example? Tell your neighbor, what else can you write for non-example? JJ, pass on one. Nick, what else can we write for a non-example? Range, yeah, range also fits in there. So anything that is not a measure of position, you can fit in there. All right? So for a hashtag, what are measures of position? Just put hashtag relative position of data. So basically, you're going to take a certain number, you're going to find out where exactly does it fit where the data is spread, whenever we graph it, okay? All right, so without further ado, we already have how many formulas? 19? Yes? Yes, Mr. Q. All right, go to the back of your notebook, add 2 more. Let's go. Known as standard score or Z-score. Here go your 2 formulas for today. Z equals X minus X bar over S, and Z equals X minus mu over the sigma, locale. Copy that. And everybody wrote down the formula? All right, so let's break this down to make sure we got it. Tell your neighbor why this one is S and why this one is low cap sigma. Talk it over to your neighbor. Why is that one that and that one that? They should know by now. All right. So, Martin, why is this one S? Sample, that is correct. Sample, and this one? Population. Let's go. Morning, Jay. Population. All right. So yeah, sample, standard deviation, population, standard deviation. All right. So with that said, tell your neighbor what this one stands for and what this one stands for. Martin, pass him one. AJ, what is this one? Mr. Marcus, can you help AJ out? Sample mean. So since he helped you with that one, by now you should know the name of this one, AJ. Population mean. That is correct. All right. And last but not least, I'm going to circle this one in red. This is just data value. and we're specifically talking about only one value. It's the same for both, okay? And you'll see right now when we go over a couple of examples how you're like, oh, I get it. All right. So, we got it? Z? Okay. By now you should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Let's go. All right. So with that said, example Q. Write this one down in your notes so you can have at least one example to guide you through your home plate tonight. And it reads, a student scored 65 on the statistics semester 1 final exam that had a mean of 50 and a standard deviation of 10. She scored on the semester 1 history test with a mean of 25 and a standard deviation of 5. Compare her relative position of the two tests. Copy that, please. Here we go. I'm going to read this once more. It says, a student scored 65 on the statistics semester 1 final test that had a mean of 50 and a standard deviation of 10. She scored a 30 on the semester 1 history test with a mean of 25 and a standard deviation of 5. Compared her relative positions on the two tests. And what does that mean? It means to come to a conclusion once you compare both tests. Question, is it talking about all the students in the world? No, so tell your neighbor which formula you're going to use for this one. Which formula? Yeah, the sample, that is correct. So let's write it over here on the side. Z is X minus X bar over S. All right? So that's what we're going to start with. And I'm going to use blue to underline the information of the first part of the problem. So this student scored how much? 65. 65 on a what? In the statistics semester 1 final, okay? And then she has a mean of what? 50. So those are the two pieces of information. What else do we need? Standard deviation of what? 10. So let's label this. This is our X. This is our mean, which is X bar. And this is our S. So go below right here in blue. Z score is X, which is 65. The mean is 50. And the standard deviation is 10. So that gives me 15 divided by 10. What is 15 divided by 10? 1.5. So the Z-score is 1.5. And you're wondering, what does that mean, Mr. Q? I'll show you in a little bit. Remember that the definition said the relative position, yes? So let's do this. Over here on the side, let's draw a bell curve in blue. And we always start with our what? Our mean, which is X bar. And how much is that? That was 50. And then I'm going 1 standard deviation up, 2 standard deviations up, 3 standard deviations up. And then I'm going 1 standard deviation down, 2 standard deviations down, and 3 standard deviations down. And we know that the norm is between what standard deviations? Tell your neighbor. The norm is between what standard deviations? Tell your neighbor the norm. The norm is what? What is the norm, guys? Oh my goodness. Between the first and the first standard deviation. Bah. Really? Come on now. We've been going over this like the whole year, pretty much. Bah. Now, this is a good example, guys. I'm going to pause the music because check this out. You guys when you get to college, many professors, they score on the curve. And what does that mean? That they use the norm to grade you. So therefore, you want to know how to do this because that's how you're going to know where you land according to the norm of the class. So watch. So here's our norm. Okay. So this person scored 65. Look up. I'm going to use red. They scored 65 if they want to know where they land according to the norm of that class. So this is what class? This is statistics. I'm going to label this statistics, stats. The norm is from here to here. So I want to know between what numbers is the norm. So what is my standard deviation? 10, right? So that means I go up 10, so that's 60. And below that it's what? 40. So my norm is from where to what? From 40 all the way to 60. Okay. So it looks like this person scored a 65, which is above the norm, yes? But how much? Here it goes. This is where this comes into play. The z-scores tells us the exact standard deviation, where they fall. The position where they fall within standard deviations. So how many standard deviations? 1.5. That means that after 1, you go halfway up on the positive side, and that's where they land. So here's, look up. First standard deviation is this one. Second standard deviation is here, but halfway is about right here. So do the wiggles right here. So this person, their 65 score lands them between the first and the second standard deviation. So what can we conclude with that? Well, Mr. Q, that they are above. So let's make a little note here. Above norm. That means they're in a very good position with that one. Does that make sense? Yeah? Yes, Mr. Q. All right. So we got stats, but what other tests does she want to compare? The history test. So let's do that again. So now I'm going to use green. So let's underline information. We have a mean of 25. That's our X bar. A standard deviation of what? 5. So that's our S. And then she scored a 30. So our X is 30. All right. So let's redo our formula over here. Z is, bless you, 30 minus the mean, which is 25, over the standard deviation of 5. So this leaves us with 5 over 5, which is 1. So her z-score is 1 for the history test. So now let's do a bell curve for that one. I'm going to use green. Right here. Hold on, let me fix it. All right. So the mean for this one was 25. Then we go 1 standard deviation, 2 standard deviations, 3 standard deviations, 1 standard deviation below, 2 standard deviations below, and 3 standard deviations below. All right. And once again, remind your neighbor, what is the norm? What is the norm? Between what and what? Remind your neighbor, what is the norm between what and what before we get the numbers out there? Yeah, between the first standard deviation. Bah! My goodness. That's our norm. Well, now we need values for that. So let's put some values to that. 25, and our standard deviation was what? 5. So the first standard deviation up is at 30. 1 standard deviation below is at 20. So that means our norm is from 20 to 30. How much did they score? They scored a what? A 30. So according to our standard deviations, where does she land with that score, everyone? At the first standard deviation. Where's that at? Right on here, on the first standard deviation. What can you conclude with that for that test? She's in the in the norm. And this is for our history. Okay. So, if you were to compare the two in regards to how she did with each of those classes, what can you conclude? What would be a statement you would write? Talk to your neighbor. What would you write in a statement comparing those two classes? Talk to your neighbor. What would you write in a statement? All right. Looks like Martin's got it. Very good, Martin. But let's go with Jacob. What can you conclude? The student. AJ, go. No. You can't pass it to again. Go. You got it. The student what? Okay, Jay, go. Oh my goodness. What do you guys say, bruh? Guys, look at it. Look at the stats. We said she was what? Above the norm. And how about history? In the norm. So what can you conclude for both classes? Yes, the student is better in her statistics class. 10Q. From 1 to 5, how comfortable are you comparing two different sets of data using Z-scores? 5, 5, 5, 5. Okay. All right. So let me send you the screen. Let's see if it goes. Yes, it did. All right. Send me a picture of your notes. Yeah. Yeah. Yeah, guys, you just need to take a step back and look at what you have in front of you, and don't get all confused with the different graphs. Just look at what we label and just come to a conclusion. Simple as that. All right, let's go to the next one. Example Super Q. Says, find the Z-scores of each test, state which is higher. So, for this one, they give us test A. They give us the X, which is the data. They give us the mean and the standard deviation. Same thing for test B. So, now that you know the process, use two different colors. There's the data. Only copy the table. And then I want you to show me two bell curves and then come to a conclusion. The question was, state which is higher. Which one's higher? I'll give you guys a head start. Go. And for the sake of time, I'm going to have AJ guide me through test A. I'm going to use, no, he's not going to pass it. He's going to guide me through this one. Test A. All right, AJ, being that they're not talking about all the tests in the world, we're going to use the formula Z X minus X bar over S. All right, so, AJ, tell me what to write. Uh-huh. Yes. Yes. Which is what in decimal? Calculator? Negative 0.4. Okay. All right, let me get my bell curve going on that one. So I start with my mean, which was 40. One standard deviation up, one standard deviation down. 2 standard deviations up, 2 standard deviations down, 3 standard deviations up, and 3 standard deviations down. All right, AJ, what's the norm from where to where? The first ones, yes, okay. That's our norm. So far, so good. Damn, AJ, let's go. So, if our standard deviation is 5, so from here to the first one, it's how much? And below? So our norm is from 35 to 45, okay? So according for test A, where do they fall? Negative 0.4. So here it goes. Look up, people. At the mean, it's always 0. Start at the mean. So if it's negative 0.4, is it all the way to negative 1? No, it's close to halfway, right? A little bit below that. So I want you to mark right below halfway mark. And this is where they land, which is the score of 38. 38. So what can you conclude, AJ, according to what you see here for test A? Yeah. What? This person is in the norm for test A. All right. So do test B, compare the both, and come to a conclusion. I'm going to send you the screen so you can send me your conclusion for both of them. All right. Bless you. And AJ in the house. Let's go. All right. Let me pass this to, let's go with Arisai. I'm going to use red. Help me for the formula. What do I write? Z. Yes. Yes, which is negative 6 over 10, which is in decimal form 0.6. Okay. So, our mean is 100. So 1 standard deviation up, where are we at? $110 and below. So my norm for that one is from 90 to 110. Okay. And where did this person land for the second test, or test B? I'm saying according to the standard deviation. Here's 0. Huh? Okay, so tell me where to stop. Here I go. About the same as the other? Let me zoom in. So look at the other one. The other one is 0 and a little bit right before the halfway mark. Tell me where to stop for this one. Here you go. All right. Looks about right. And that score was what? 90 what? 94? Okay. So, but this person's still in the norm, but what can you conclude from both tests? Talk to your neighbor. What can you conclude from both tests? What do you guys see? What do you guys see? All right, looks like Martin's got it, but let's go with Matthew. What can you conclude? The student did better in test A than B. Hands if you agree with that. That is correct, because look up, guys. Because the more we go, look up, the more we go in that direction, it's better. Is that correct? On the positive side? Which one was closer to that direction? The test A. This one was a little bit to the left. Okay, send me your notes, please. All right, those of you following on YouTube, I'm going to stop right there, give you guys time to practice the home plate. See you guys next time. Bye.